So we're on 7.3, double angle formulas. Now, the double angle formula is developed from the compound angle formulas, which we just did in 7.2. So let me show you, where can I show it? I should have had a little bit more space on this page. So I'm going to do it on a separate little post-it note here. So this double angle formula here, if I have sine of 2 theta, that's actually the same thing as sine of theta plus theta. Right? So I'm bringing it back to the compound angle formula. If I use the compound angle formula, this is going to be sine theta cos theta, right? Plus cos theta sine theta, according to the compound angle formula. But if that's sine cos plus cosine, aren't they the same like terms? These are like terms, so that's sine theta cos theta and cos theta sine theta. Those are like terms. So that you can simplify to be 2 sine theta cos thetas. And that's where they got the formula. So all of the double angle formulas are actually just the compound angle formula, but with 2 of the same angle. So instead of having an AB, it's an AA or a BB. It's 2 of the same. So if I do that with so that's the sine. That makes sense there? Okay. Put that on the side here. And then if I did that with cos, okay, so the cos formula, so without looking at it, I'm going to cover that up, and I'm just going to be 2 cos theta. And there's actually 3 different variations, so I'll show you that in a second. So I'm going to take that one away. So if I had cos 2 theta, that's actually cos of theta plus theta, right, 2 of the same. Break that down to be cos, and then this is minus, right? So minus sine, cos minus sine. Cos times cos is cos squared, minus sine times sine is sine squared. That's formula 1. That's the first one. So that's our first formula right there. Cos squared minus sine squared, that's our first formula. From there, they went on to the next 2 formulas. Then they said, but we know that this, from Pythagorean theorem, so Pythagorean theorem, I'm going to do another post-it note here. So Pythagorean from last year is sine squared plus cos squared equals, remember this? 1. Whenever we had a squared, we would isolate, so I'll bring the sine squared over here. I'm isolating for this cos squared here, this one here. So I'm getting a cos squared theta equals 1 minus sine squared theta. So this goes in here. So see this one, we're going to sub that in. Sub. And that will be equal to 1 minus sine squared theta, right? That's this part. This part's still sitting here. Okay, and what do you see here? Those guys are like terms, right? So like terms, does that make sense? So like terms, this one's like terms with this one. So I can write it as equals 1. If it's minus sine squared, that's minus 2 sine squared. And that is equation, oops, I skipped, that's equation 3, the third one. Right there. What if I wanted the second equation? Instead of subbing in cos squared, I would have subbed in for sine squared and switched it to cos squared. I would have gotten this version. But do you see how they're all exactly the same? They're just reworked a little bit with the Pythagorean theorem. So again, we will give you these formulas. This is how they were developed. In the past, when we didn't give you the formulas, you had to be able to figure it out yourself. So we would say memorize it, and if you can't memorize it, you should be able to figure it out by doing this yourself anyway. We do give you the chart. It's still better if you can recognize it. because what happens is that I'm going to give you this side, the right side, and you have to know cos squared sine squared is actually cos 2 theta. You have to be able to go from the right to the left and the left to the right. So recognizing it helps. So if you see something with 2 sine cos, you should say, oh, I think that's the sine 2 theta from, oh, and you can check your sheet, right? So these ones I'll put into a separate little piece of paper, but that is how we developed it, okay? And we have this. Okay, and I'll take this away. All right. So that's our separate page there. So these are the formulas, right? So for the cosine function, there's 3 variations depending on if they subbed in the Pythagorean identity. The double angle formula for the tangent, the way, if you remember the addition formula, tan 2 theta is actually, oh, sorry, tan 2 theta is tan of theta plus theta, and the formula for tan theta plus theta, again, you might not have this memorized, but it was tan theta plus tan theta, 1 minus tan theta, and then they just went, well, these are like terms. Those are like terms there, right? So that's like term with like term. So then they said that's the same thing as 2 tan theta, and here it's tan times tan, so tan squared theta. So that's where they got the second. Also, they got it from sine over cos, but that's harder to develop. Okay, so that's the formulas. Again, you have the reference sheet. Okay, so everyone will have the reference sheet with these boxes on it, so you can use that. But they come from the compound angle formula. That was what I was showing you on the extra page there. Okay, so it's from the compound angle formula. Now, let's try to use it. So we're here now. So when I give you something here, 2 sine cos, and they're the same angle here, right? So 2 sine cos, you should go, wait, I feel like that is the double angle formula. Yes, it is. It's 2 sine cos. And you'll see they're the same angle, right? The same angle, 2 sine cos, and it is this double angle formula. So you should be able to recognize it and go backwards. So from this right side, I want you to go backwards to the left side. So we're going to take this and we're going to say this is the same thing as sine of 2 pi over 8. Okay, it's the same thing as 2, and this is my pi over 8. Double that angle. Then it'll say, it'll keep going with sine 2 times pi over 8 is pi over 4. Right? 2 times pi over 8 is pi over 4. Read the instructions. This instruction was better than the other example we had where I said, I don't know if I would want to finish it. Look, it says simplify, and then it says then evaluate. Remember, because the other one you're like, I'm not sure if I would keep going. This one's specifically saying then evaluate, so I want you to finish it off. So I would take this and go, okay, equals, and pi over 4, if you have your special triangle, you don't have to draw it, but, right, so it's pi over 4. I know that this is 1 root 2. You probably have that written somewhere on your page, and you know that sine of pi over 4 would be 1 over root 2, which we would never leave because it's not rationalized. So root 2, and then that is root 2 over 2, and we're done. Right, so I do want to simplify it. That's the first part. And then it says evaluate, which means keep going. All right. Now, for the next one, again, you should hopefully go, wait, 2 tan, 1 minus tan squared. I feel like that's this double angle. And it is. You go, oh, yes, it is. So I take this, and I'm going backwards. So this is going to be equal to tan of 2 times whatever this angle is. It's pi over 6. So keep going. That's be tan of 2 times pi over 6 is pi over 3. And it asks you to evaluate, so keep going with that. So look, This says evaluate, which means then I want you to for sure finish it off. And this would be equal to, and if I have my special triangle here, that's pi over 6, pi over 3. This is going to be 1 to root 3, and that's going to be pi over 3, so it'll be here, root 3 over 1. Don't leave it like that. I do want you to finish it as root 3. I know it's a ratio, but we want to finish it. Okay, so right side, left side. We don't always ask you to go from the left to the right. We'll give you the right side, you go to the left side. Right, so you have to use the formula backwards and forwards. Okay, let's try it again. Express as a single trig ratio. So it doesn't tell you the method, and this is why I said you have to recognize it. You have to go, wait, that looks very similar or close to the double angle formula for sine, right? So it's sine cos, 2 sine cos. But it's not 2. It's 6. So then let's fix that and go, okay, this will be 3 times 2 sine cos. Right? So it's very similar, and you go, oh, I can get the double angle out of that. If I take the 3 out, and I go 3 times 2 sine cos, then this part here can be rewritten as sine of 2x. And then this, you keep the 3 in front, and that's it. So it says as a single trig ratio. It always finds hard when you read the question. You're like, wait, what do you mean? They want you to simplify. They want you to go from the right side of the formula to the left side of the formula, which makes it into a single trig ratio. Instead of 2, there's a single trig ratio left. Okay, so the next one you go, okay, recognizing it. 1 minus 2 sine squared. Okay. That feels very similar to, familiar to 1 minus 2 sine squared. Right, so it's the double angle cos. So that means whatever angle's here, we double it here. We're going backwards to this. So whatever angle's here, we're doubling it when we go backwards. So grab this one, and we're going to say, so this is the same thing as cos of 2, and then grab the angle, which is x over 2. So double that angle, and then simplify it. So this will be the same thing as cos 2 times x over 2. It's just cos x. Okay, that's it. All right. Next question. I have a ratio. We've seen this question a lot, right? So we give you the ratio. So we give you the ratio here, sorry. Okay, tan is negative 3 over 4. We know that that ratio is TOA, so TOA, so opposite over adjacent, right, TOA. Then we know, right, opposite over adjacent. We know which quadrant it's in, so I'm going to draw the quadrant that it's in. Okay, I'm going to draw it over here. I don't need too much room, so you don't have to write too small here. I'm just going to draw this pretty big so you can see it. And it's in quadrant 3 pi over 2 to 2 pi, so it's over here. You don't have to do it with a ruler. I'm just doing it so that my notes stay a bit neater. So it's here. Drop it straight down, always towards the x-axis. So again, you don't have to do this with a ruler. I'm just, for our notes, we have a bit more time, so I'm doing it with a ruler to keep it neat. So we know that's it. I reference angles here. So right away, without even knowing anything, I know that my opposite is negative 3 and my adjacent is 4. So if I'm going to label this, I would go with negative 3 because it's heading down, right, and 4. And we're looking for those negatives and positives now, right? Anything drawn on a quadrant, you look for the negatives and positives. So it's a negative 3 and a 4. TOA, we've got that. Now I'm asking you, so I drew that, I don't even know what the question is. I just know that that's the information I got. I want you to calculate cos of 2 theta. Okay, so this is not a big question, so I'll just start it over here. So cos of 2 theta equals. Okay, cos of 2 theta equals, and I have my formula. I have 3 choices for the formula. Always, always, always. Whenever you have cos of 2 theta, there's always 3 choices. So this one here, this will always give us 3 choices. 3 choices for the formula. Always gets 3 choices. The sine 2 theta, there's only 1. This one, there's 3 variations. They're all about the same. Sometimes one is easier than the other, but really you've got 3 choices. Right, so always 3 choices for the formula. Which one do we want to use? So let's look at our formulas over here. So we have our formulas, and we go, okay. We have, which one are we doing? So cos 2 theta. So cos 2 theta, I have these 3 choices. I can do cos squared minus sine squared. I can do 2 cos squared minus 1, or 1 minus 2 sine squared. Your choice. Now, this one requires me to do 2 ratios, and this one has just 1. So most people go, I like these 2 because it seems like a little bit less work. Both of them will be fine. So you want to do, let's try the 1 minus 2 sine squared theta. So it's half. If that's 2 theta, that's half of it. Right, so 2 theta becomes the half, so we got that. Right, so looking at our angle, so this is 2 theta, then this is half of it. So then we go to our tan theta, and we need O over H, opposite over hypotenuse. I'm missing the hypotenuse, right, missing the hypotenuse. So then let's go over here, and let's find this one using Pythagorean theorem. So it'll be 4 squared plus negative 3 squared. Right, so 16 plus the 9, so that's 25, so that would be 5. So I put 5 here. Okay, 5 there. And then we're just going to go ahead and solve it. So we just want to plug it in. But remember, look, it's 2 theta, so it's a theta. It's half of whatever that angle is. So this would be 1 minus 2. This is going to be sine, which is from this angle, opposite. So negative 3 over 5. And remember, it's all squared, the ratio all squared. Okay, so that's this line here. Keep going. 1 minus 2, this becomes 9 over 25. Okay, and now it's just fraction work. It's over 1, numerator times numerator, denominator times denominator. We're going to get 1 minus 18 over 25. And we've got mixed fractions, so 25, 25, big arrow equals, and that would be 7 over 25. Done. Questions?